Hello everyone, how you all are doing? So welcome back to our channel, and today we'll be covering some of the basics to advanced topic of C programming. And why we are doing this, let me set the context. So basically the people who are old to the channel, they know that we completed our backend mastery, we almost completed our applied operating systems, but there our primary language was C++, right? And there were folks who want to start applied operating systems, and they are not able to just because of the C or C++ experience, right? So I know there are the courses who teach you about different topics about C or C++, but the thing is they are not explaining by make files, C make, attributes, and how production level code is written. So basically it is more into that path. So today we'll be taking it as a beginner point of view. Why? Because this is our C programming crash course, and the next one will be C++ crash course, right? So before jumping to C++, I want to cover some of the more than enough topics so that you can start development in C++. I want to cover those topics, right? So for that, this course is necessary, or you can say a prerequisite for C++ course. And for the folks who are new to our channel, you can subscribe, like, comment. And just an announcement, or a thing that I want to tell you, that from now on our content will be in English. Our old content like applied operating system playlist, right, our interview guides, our roadmaps, our backend mastery playlist, all these playlists are in Hindi, right? And that is because we started this channel as Hindi channel only. Why I am shifting now is because there are some folks from Bangalore, Hyderabad, who want me to teach them the low level stuff in English, or at least English, right? So that is the take. I'm not targeting any international audience. I'm just making it to make sure so the people from India, all over the places from India, they can learn about it. They can learn different stuff so that I can explain them better, right? So no worries, my English will get better with upcoming videos, but it's new for me also. So I hope you will share on Twitter that you are doing this, that on my channel. And yeah, let's start today's video. Okay, so let me explain the index, a plain index. So basically we will be covering some of the C basics, right? Like what C programming language actually is, right? How you can code in C. So basically very basic topics are data types, right? And we'll not cover it in broad way. We'll cover it in depth, like how data types of different bits or bytes behaves, right? Let's say int, let's say char, all these data types, why they are of, let's suppose, 1 byte, 4 byte, and what does that mean? Unsigned int 32 bits, all of that stuff, right? We'll do that because when you will write code, you will majorly see uint kind of things, right? So data types will we'll cover about numbers, like number arithmetic, very simple arithmetic constants. These all are basic topics. You can refer the timeline. And user IO is important whenever you are writing a code and you want user to input some something to the program. Then we need input output, and arrays, normal things, right? And switch statements, if else, these all we will cover, right? Now the important part is we'll cover how C language actually works, right? What is the delinking, not delinking, what is the linking of a library, what is a header file, and how to include them. These header files are basic topics, but when it comes to linking, sometimes you have to make a complex project, and while it comes to running a project, that is quite difficult for a starter. So in C language we will cover this stuff, like how it works, what is linking, what is compilation, right? And what are object files after compilation, what does actually happen behind the scene, right? Then we'll cover some memory management, right? That in C, how pointers work, how memory is allocated dynamically, compilation time, runtime memory allocation, all these stuff. Then we'll cover about file IO, input output, right? Then we'll cover some of the pointers, right? 2D pointers, or I should say 2D double pointers, right? So and then the next thing is कि pointers arithmetic हम सब cover करेंगे, right? ARTHEMETC हम सब cover करेंगे, right? But the thing is, in this video we'll also cover a major part, which is Makefiles. This is the part where people get confused, right? So this is the part where I got confused also. So Makefiles is basically a build tool that people use to build their C projects. And when we'll take C++ crash course next time, we'll do oops, right? We'll do STL library, right? We'll do some of the other things like how header files are exactly used, right? We'll check how what are the polymorphism, basically encapsulation, all this stuff in oops only. And we'll also cover CMake. CMake is basically cross platform build, I will not say build tool, I will say an extension, so that it can generate some build files for different operating systems. So we'll cover CMake. We'll make our own chat room, right? Here you will come to know that async IO, what is async IO, what is sync async, and we'll make our own WebSocket server, right? So these are the major two projects. But for this course, for C++ course to happen, you have to cover these all stuff, right? If you are a beginner or an intermediate programmer in C. So yeah, that's about the index. Let's proceed to our coding part. So people who are running all this stuff in Windows, I highly recommend them that please install WSL. And people who are in Mac, you can install UTM. Why? What exactly is that? So basically WSL, I think Windows Server Linux, I'm not sure about the full forms, but these are not your generic softwares. These are like virtual machines which gives you power to run a inbuilt machine in your local system so that you can run another operating system in your host machine. So what does that mean is, let's suppose I am running Windows or Mac for say Windows. Now whenever it comes to low level programming or C++ programming, anything, please always prefer Linux. Why? Because there are so many inbuilt things that Windows doesn't have, that Mac doesn't have. So I would say that switch to WSL. How to know how to install this? Yeah, see, VS Code tips the remote WSL connection, right? And you can also type UTM, right? Connect to remote server with SSH in VS Code. I think it is via UTM, or this is setting up VS Code for remote access. So this you can do, right? What will happen is, I can give you an example of Mac because I'm running in Mac. So this you can see, this is my UTM, basically UTM virtual machine, where I have installed Ubuntu server, not Ubuntu GUI. I installed Ubuntu server, which is just a CLI operating system. And this server is running in my virtual machine, and I have just logged into that, and I have connected to this server in virtual machine in VS Code. So here somewhere you can check. Let me open my terminal. So here you can see Lovepreet is the username. Here you can see, right? So I'm connected to this server. Yeah, that's it, right? That's how you will set up your environment. Pause this video, set up your environment, come back. Okay, so this is my new folder where I'll be coding your few examples of C, and then we'll be heading towards some good things, right? Okay, let's make an src folder, source folder, where we'll keep our C files, and let's make hello world, your first C program, right? So again, if you are already done with beginners type of stuff, you can switch over to another timestamp. For that you can refer timeline. Okay, timestamps are there, you can refer. Let's start. So basically for C programs, you have to make sure that file extension is C, and you can like type anything, right? But we have to type the instructions that C compiler understand, right? So first instruction that we have is to include something. So include is nothing but a pre-written code which is already built by someone that you can import into your own code, right? What does that mean is, let's suppose I am importing this file stdio. So if you are running a Linux machine, WSL, UTM, whatever, and you have connected VS Code with your virtual machine, so IntelliSense will automatically comes. If it is not coming, then just go here, search C++ extensions, got it, and just install this C++ extension pack. Restart your ID, or it will you don't have to restart, it will automatically reflect, right? Okay, so first file we have to include stdio hrets, let's say. And in every C file, if you want to run that C file, you have to make sure that it knows the starting point, and the starting point here is main, and this is the function. Function means this is some kind of set which will include some instruction that will run, right? And this is the return type. So there are different types we'll talk about. So first type is integer, right? But this is a return type. What this function will return, this is the function name, this is the function basically parentheses where you can pass parameters, right? Right now don't think more about it, just type this whatever I am typing. So this is an inbuilt function printf. If you will control and click, of if you are in Mac, just command and click, you will be able to go inside the function. And this function is defined in stdio.h file, and we are importing that file. So this is a predefined function and we are using it. How to use it? This is a function, we have to give it something which it will print hello world. Okay, and because this function is int, so you have to return some integer. So return any integer, any number, right? Okay, so this is the function. How to run this function? So there is something called compiler. What compiler is, how C program runs, we'll come to that. But first we'll figure out some syntax, so that we know enough things so that we can run that code, right? So that we know enough things before jumping to that point, like how this program works. We should know how the program is written, right? Okay, so gcc wherever my folder is. So this is my folder and my file is hello world. Okay, and I want to compile this file using gcc compiler. So basically, if you are in Windows, you are not running VM. Like if you are stuck on your decision that I don't want to run VM, you have to use mingw, right? Or nmake for Windows, guys. Nmake is from Visual Studio, not Visual Code, but forget about it. I will recommend to use Linux. So this is compile my file and provide me the main executable. So this is not a file that will run. There has to be some executable, some object file that my computer assembler. What is assembler? Again, I will tell you. So my computer assembler will understand, or in plain language now, like I'll tell you after what assembler or machine coding is. But as of now, you can just say that this is the file that my machine can understand. This plain text my machine can't understand. It can only understand 0101, right? Main. So my main file will come here and I have to run this hello world, right? On my CLI or terminal, hello world is printed. So this is your first program. Congrats, you have coded something, right? But this is a newbie example. That's not what we do on this channel, right? So that's it. I mean, what can we say, right? That's it. So there are some white space characters, right, that our computer interprets as different characters. Some of them are \t, \n, right? So if you'll give it \t, let's see what will happen. Again compile, you have to again compile. It gave us some spaces, and basically it's a tab gives you 4 or 8 spaces according to your machine or IDE. If you'll give it \n, it will give you a new line. So basically, okay, compile again. So hello world is printed. Then on new line my CLA is like my tape CLI went to, right? All right, good to go. Everything is fine. Okay, so here how I can print a star here is, let's suppose this star, right? Okay, and you have noticed something, that I am returning nothing now. Will this program run? Like in some languages, if you are mentioning that this function will return int and you are not returning that value, that compilation or interpretation, whatever, will give an error, right? But let's see what will happen here. I think it is able to run. It is able to run, which means there is a default value of main function that you can comment what is the default value of main function return, or you can, like after few videos, you can use this function and print the return value of this function. You'll know how to print that. Fair enough. Okay. Okay. Printf. Bytes not printing anything else. Oh, okay, I got it. Okay, it's good that it happened, right? So if you have noticed, I was saving this file and again compiling it but I was not able to see stars, right? What happened is basically I have done this earlier. I did this this thing. I've never provided the output file name. So by default in Windows it will generate something called, I think, a.exe. In Linux it will generate a.out out. So I'll run it. I have not given it any object file name. Let's run a.out and you will see the stars. Now the first assignment for you is to print this kind of pattern. Everybody gives that assignment, so that I am also giving. So how I am commenting, you can see. So how you can print this pattern, just comment down. Okay, let's go down to the next thing, which is variables. Okay, so how I have imported this template is that I have installed my extension, which is C++ extension pack, and it helped me to basically import this predefined template, right? What these arguments are, we will see later. Okay, variables. So basically we'll see everything, right? Most common variables are int, char, right, double, float. These are the most common ones, right, which are most commonly used, right? So let's see what exactly they are. So int a is equal to 32. Instead of a I will say my age is 24. Okay, now printf my age is, can you do this in C? Let's see. Okay, now it gave me warning, format not a string literal and no formal arguments, printf whatever. Okay, we'll know once it runs. So it given me some special characters, right, which are not UTF. Okay, which are special characters. Okay, so what exactly is that? In some languages it run, right, it is able to run, but here in C you have to provide some kind of formatting, right? And here it is not a string, not a character, so you have to give D, means it's a kind of digit, right? You can say it is a kind of integer, so for that you need a formatter D. So it will replace the age here, that's all, right? So you can see my age is 24. So this is an integer, but that's not the interesting part. Let's cover char also, right? So char is nothing but a character, right? Character, let's suppose my prefix or my first name, first character is L, right? In C, if you are writing a character, then you have to make sure that single quotes are there, and if you are writing an array of characters, then double quotes, right? What is an array? We'll come to that. Printf, let's suppose I am basically pasting this only, and here the formatter needed is character. So my, let's copy this only okay, and this, okay. Now the output is messed up, as you can see. So basically I have to make sure that I am giving a new line character here, so that next line is printed on the new line. Again compile and run. So my age is 24, my first name, first character is L. Let's give it double quotes and then run. We got some warning and we'll get some special character or garbage value, right? Some value that is being stored there from the on the memory which I am trying to access. Okay, let's go ahead. This is not a fun part. Okay, the fun part is we want to define some string, right? So let's suppose I want to define a string. Can I do that? I don't think so. We can do that. So what you have to do is, let's suppose you are storing a string of 50 characters, right? This is not a string, this is an array. What exactly is that? Let me define that. Okay, so basically whenever you are dealing with arrays, so arrays are nothing but a data structure, right? Where you can store contiguous elements of same data type. Let's suppose this is my int array, int whatever name it is, let's suppose 5. So basically it means I can store 1 2 3 4 5 elements. Okay, 5 elements of integer type. Integer means 1 2 3 minus 1 minus 2 whatever. I can't store a b c here, right? That is what array is. So in interviews, whenever someone asks you what is an array, it is just a contiguous block of memory. Contiguous block means I will tell you what is contiguous blocks when you will come across pointers, but as of now you can just treat this as a continuous block which is like lying one after another, right? Okay, now let's discuss about integers. Now in most of the architectures or computers, integer is of 4 bytes. What exactly do I mean by 4 bytes? So basically there is 1 bit, right? 1 bit means 1 or 0, right? 1 or 0. If there are 3 bits, let's suppose 1 2 3, right? So it can be 1 0 1, 1 1 0, 0 0 0, 0 1 0, right? These kind of bits. So these are 3 bits, right? And 1 byte is equals to nothing but 8 bits, right? Now the point here is, if I am using 4 bytes for integer, it means 32 bits are there for my integer, right? So if I have a integer of 4 bytes, that means I can have 32 bits, like places for 32 101010 pairs. The only thing is you can come across uint also, unsigned integer in C or C++, or int also. So what is the difference? So basically, let's suppose my integer is of 4 bytes, right? 32 places and so on, right? I have only highlighted some 7 places. So if I'm using int only, that means it's an signed integer. Signed means first bit will be used for sign or unsigned, right? Which means if it is 1, let's suppose, then it will be a negative number. If it is 0, then it will be a positive number, right? Let's suppose this value is, or like using these bits, the digital, like the not digital the 10 base value, the number representation is coming as 25. Let's say 1 means minus 25. If it is 0, then plus 25, whatever the like unsigned bit, right? So basically whenever you have 32 bits, right, from those 32 bits 1 bit is assigned for a sign, plus or minus. So only 31 bits are left to represent your number. So 4 bits of your integer, 4 bytes of your integer means 32 bits of your integer can accommodate how many elements? Minus 2 to 31 to 2 to 31 minus 1. Why is that? Let's take an example. If you have 3 bits, how many numbers you can generate? How many numbers you can generate is 2 to the power 3, which is 8. 8 numbers you can generate, basically 0 1 2 3 4 5 6 7, right? So 8 numbers means 0 to 7, right? If we keep this bit as a signed bit, right, then how many numbers you can generate is 2 to the power 2, right, include 0, 2 to the power 2 minus minus 1. What does that mean is कि how many integer I can generate is 0 and from यहाँ से लेके यहाँ तक. Okay, now the point here is 2 to the power 2 minus 1 is 3, right, 3 minus 4. So basically you can represent minus 4, minus 3, minus 2, minus 1, 0 and 1, 2, 3. Okay, so these are the numbers that you can generate. So you can look more about it on internet, but this is the basic representation, that if integer is of 4 bytes or 32 bits, then the numbers it can accommodate is minus 2 to the power 31, because first one is signed bit, 2 to the power 31 minus 1, right? So basically it's 0 to 2 to the power 3 minus 1 if it is 3 bits unsigned, right? So that's why when you will use uint, means unsigned int, then it is a 4 bytes, then it's unsigned only, right? You can use it here, unsigned. So that means okay, it's not supporting uint. Okay, so this is unsigned int. Basically it is because my types.h file has this defined unsigned integer as uint, or you can generally use like this. Okay, this is also one of the case. So if you're using uint, then basically it means that it's unsigned. So first bit is not a signed bit. All 4 bits can be used to represent your decimal number. So it will be 0 to 2 to the power. So basically it's 4 bytes, 32 minus 1. Is it correct? In last case we had 31. I think it is correct, right? Or I'm wrong. Just verify on the internet what exactly does it mean. And for the people who are very beginner, they can just look how to convert from binary number to digital or decimal number. Why I'm talking about digital, or vice versa. This is the topic that you have to research, and the people who are old on our channel, they know that if there is any topic that you have to research, then you have to research, right? That's how you learn. I will not spoon feed every single point, right? So that's what an array is, that's what signed integer, unsigned integer is, and that's what integer is. Character in general is of 1 byte or 2 byte, depends on your machine. Let's suppose it's of 1 byte only in our system. How to check that? Let's see. Printf size of character is %d and size of function, let's say use. Okay, now it is saying that use ld, because basically size of character will return long unsigned integer. But let's try what it will do. Okay, let's print it prettier. Okay, size of character is 1 byte only, I think. Okay, great. LD, why it's saying LD? Because the formatter that we use for long unsigned integer is LD basically, right? It's long decimal kind of stuff. Okay, now it's fine. Now it's giving warning that for a single character don't use double quotes, use single quotes. Now no warning will come. Okay, fine. So this is an array which can hold 50 elements, but how many elements I am giving it to? 1 character, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But how it is printing basically my name? Why isn't it printing after my name's length, right? My name is %s is basically string name. Okay, my name is Lovepreet Singh. How is it able to print like 1 2 3 4 5 6 7 8 9 10 11 12 13 around 15 characters, whether I have given it 50 places. Why? So basically what I'm asking to you is key, I have 50 places, right? In an array I have 50 places, so on 50. So basically there is something called indexing. So first element will have index 0 1 2, it's 0 based indexing, okay, and so on 49. So if you have elements 10, then its index will be 0 to 9, right? So we can access elements from array in constant time. What does constant mean is you don't have to go through all the array one by one. If you know the index, let's suppose I want to take out the integer, the character, whatever the array, the data type is stored into this array. If I want to take that out, I don't know the index, then it's a problem. But if I know the index, then I can just go to the memory, pull it out, right? Every index is mapped with some memory. Okay, it will get clear in pointers. So now in this array I have 50 places and my name only reaches till 14, 0 to 14, 15 characters. Why it is not printing the garbage value here, whatever the stuff is stored in memory in these locations, my RAM, right? At the end this array is stored as a contiguous memory block in your RAM. Why it's not returning any garbage value from those indices, whether it is returning instead it is returning 0 to 14 characters? Because whenever you initializes an array and put something in it, let's suppose this array has 1 2 3 4 5 6 7 elements and you put only 3 elements into it, A B C, you initialize with this, then what it will do, it will end the array with this special character. So in C it knows how to end an array, so it will only store the characters up to this point. Otherwise there is never a point for a C program to know up to which length it has to access. If we are providing 3 characters and more memory is available to it, then it has to do something so that program stops after the length that we have defined. So that's what a ending character does, this special character does. So this is what is happening. So 15 places are covered by this, and last place, like the 16th place or 14th index, is covered by special character, which is an ending character or null character. Okay, the only point here left is key, if integer is of 4 byte, character is of 1 byte, how many bytes will an integer array of holding 5 ints will take? How many bytes will character array of holding 10 characters will take? Just comment down and you will know. Okay, pause the video, comment down and then watch it. So basically if you have 5 elements in an array, 1 2 3 4 5, so basically 4 byte 4 byte 4 byte 4 byte 4 byte, so 4 into 5, 20 bytes. So there is a shortcut which is key, the length of array, whatever the length of array, into sizeof function. You can use sizeof int. So basically length is 5, size is 4 bytes, it will come 20. You can do this. Okay, my length is, never mind the spellings. Okay, my length is d name dot, so what you have to do is size of name. Let's see what will come out. Size of my length is 50, right? It's coming straight 50, right? Now let's do one thing, which is my length is, let's suppose 5 into size of character. So size of character will come as 1 byte, or let's say int. So size of character int will come as 4 byte into 5. How much it should come is 20. Everything is good. Okay, let's move on. फटाफट करेंगे अभी. numbers.c. Okay, So there are only three things you have to note, which is addition is just 5 plus 4, that's it. And let's do in that only. Okay, so there are only two things that you have to take care of. Is some subtraction, everything is very simple. You just have to do like sum percentage d, and you can sum like 5 plus 4. Or if you want to make another function, let's make another function which will return in sum. It will accept two integers, right? And it will return a plus b, right? If it is subtraction, a minus b. If it is multiplication, a into b. If it is division, a divided by b. If it is a remainder, a percentage b. Those who don't know about modulo operator, just look at the internet what modulo operator does. It will just divide two numbers, whatever the remainder is left, it will return the remainder. So basically when you divide 5 by 2, the remainder left is 1, right? ऐसा कुछ बचता है जो डिवीजन के बाद आता है, which can't be divided by the number, that is the remainder, right? Okay, whatsoever this thing. And let's see one thing, which is sum of, let's suppose here you will take a plus b is something. So first formatter we need a, which is 5, second formatter 4, and here we can say 5 4. It will call the function, it will get the result which is integer, right? It will put that here. Okay, sum of 5 plus 4 is 9. Okay, let's suppose division अगर करते हम तो कैसे करते? So how to divide? It's just printing, bro. You can put anything in the string. Main result will come here. 5 4. Let's suppose division 5 divided by 4. A divided by b. So what it will give to you is, okay, let's put some new line so that result will come in new line only. Let's do that. Okay, so it's coming as 1. 5 तो 4 से divide होता ही नहीं है. It would come as 4 6 4 2, so 1.245 something, right? ऐसा कुछ आएगा, right? Let's divide 5 divided by 4, 1.25 something, right? So ऐसा कैसे हो रहा है? How it is giving you as 1 only? Because it takes something called floor, right? Let's suppose I divide 5 or 3 by 2. It will divide 3. Let's suppose 10 divided by 3. It will come as, I think, let's check. It's coming as okay, here I am dividing 10. Let's print nicely. It's coming as 10 divided by 3 is 5. So if you'll divide this, it's coming as 10 divided by 2, bro. It's 3. Okay, it's coming as 3. How? 10 divided by 3, because it's 3.33. so there are two things, which is, one is floor, one is seal. So basically when your result is not a whole number is there are no decimals, right? After a decimal point there is nothing, that is a whole number. But if you don't have natural number, whole number, integer, what you can do is, in C program it will take just the floor. So the floor of 3.33 is 3, seal is 4, right? 3.333 उसका floor है, 4 उसका ceiling है, छत है. So if after taking division I will take seal, will it print the result as 4? Because 3.33 ceiling is 4 and floor is something else. So let's see what it will print. 10 3. It's still printing 3. Why? Let's make it include math. Okay, too many arguments to the function seal. Okay, what kind of arguments it take? Let's check. Let's include one library from where this function will come. Okay, got it. So seal takes one double, right? So seal takes one double. So let's call sum 10 or not sum division 10 3. So what it will do is it will call division function first, which is 10 divided by 3. Then whatever the result is, it will give to the ceiling, right? Let's see what happens now. So the result is still 3. It's not giving you 4. Why? Because this a divided by b itself will give you an integer, which is not a ceiling integer. It will automatically round off, right? Let's say we'll return double here. What will happen then? Undefined reference to seal division integer. Let's see what is the problem. Okay, let's remove seal as of now and let's try what is it trying to say. Okay, now even if I removed the seal, right, it's returning you 10 divided by 3 is 3.33. Let's remove this. What is this? I don't know. Let's say now it's giving you 3. So basically whenever you're dividing a divided by b, what is happening is you have two memory location a b. You're dividing both of the integers, right? Now when you're dividing them, before extracting the result, you have a buffer. So what happens is I'm returning from here, right? So a function is returning something. So this is a function, let's say, and in its body it is returning let's suppose 3.5. in C our return type is integer, right? So what will happen is this is an intermediate result which formed from a divided by b, right? This intermediate form of result has to saved somewhere, so that this, now let's say my main function is using this result. My main function is calling this function. Let's suppose function name is a. So my main function is calling this function. So whatever the return value of this a function is, it needs to preserve that in, let's suppose, b, right? So basically, let's suppose in my main function I am storing int result is equal to sum of two numbers. So this number is getting stored in result. Before getting stored, it is returned from here, an function, right? From a function. So this flight, so he is landing from point A to B, and before going from A function to B, there is something called buffer on an intermediate data storage. So there is called buffer, right? That buffer memory location will hold this result for some time, and then this result will be like transferred to here. That's what happens, right? So before transferring that result, I am typecasting. What does typecasting means here is कि whenever you are dividing, put that result through a typecast, or let's suppose there is a curtain, and you are wearing something, right? And after a curtain there is a room, and you are changing something after a curtain. So this is a curtain, right, which is telling that whatever the result of a divided by b, make sure that goes into the double. Double is nothing but a kind of data type which can hold decimal numbers, right? Integer always hold 2, 3, 4, a whole number, right? Like it can't hold 2.1, but doubles can hold 2.1, 2.11111, 2.3, these kind of numbers. So there are two data types, float and double, right, which are used. Float is of, I think, 4 bytes maybe. Double is 8 bytes, again depending on the architecture. So make sure when you want so many decimal long or large decimal numbers, you use double. So float is similar, just replace double with float. Okay, so let's do this 10 0. So I'm dividing now INF. There is something called INF given by it, right? Let's see. Okay, type of is not a function in C. Never mind. There should be some function type of kind of, I don't know. Okay, never mind. But if you divide 10 with 0, right? Let me print it prettier. 10 divided by 0 is infinity. Every number divided by 0 is infinity, but it's not throwing an error, not a rare error. But let's see, in division it's returning double. What if we want to return integer? Will that cause any difference? Ten divided by 0 is 0. 10 divided by 0 is 0. Now this is your homework. Why it is returning 0? 10 divided by 0, I don't know. When we had double, it's returning something called INF, right? So that's it in the variables point part, right? Now the next thing is constant. So constant is nothing but here I have variable a is equal to 5. Now I can assign it as 6, right? Let's see what the value before changing the value of a is. Value of a is percentage da. There is something interesting happened although 10, when I was dividing 10 divided by 0, you must have noticed that when I was running my program like GCC, when I was compiling my program, there was no compilation error. But when I ran the program, there was one error which is called runtime. What is compilation? What is runtime? You can search, but when we will come to the part where how program in C runs, you will come to know about that also, right? So don't mind about that as of now. Okay, so what will be printed here? Let's see. Value of a is 6, right? Let's okay, and GCC variables, value of a is 5, then value of a is became 6. Now this is called variable. So basically where whatever the memory location a is being stored to, that is holding 5 integer, right? And that, like the name in our language, in our high level C language, we gave it as a. Now this a can be reassigned to different value, right? But what if I make it as const? What will happen, right? It is a compilation error. Now here you can see before running into program, my IntelliSense, what is IntelliSense is that you have installed your extension here, C++ extension pack. There must be something called IntelliSense if it is giving. Okay, I'm not sure, but the IntelliSense is being able to compile some of the code part whenever you are writing itself, so that you don't have to run the code to find the errors. So here you can see squiggles, and expression must be a modifiable L value, right? So whenever I will remove it, it is definitely fine. So whenever you are making it const, it means once it is assigned, it can never be changed. What happens now? I'm saving it, right? I saved it const. I am not declared any value to, I have not stored any value, and after that I have changed the value. And let's see what happens. Assignment of read only variable. So this is called assignment, right? Assignment after declaration. This is called assignment during definition or declaration, whatever. So this will work, right? So const just means that the data type, whatever data type your container is holding, that container value can't be changed. Okay, got it. Variables, constant. Now the most interesting part is user IO. Let's say io.c. Okay, Okay, got it. So user.io, let's suppose I want to ask user whenever he's, now we are running the program, compiling the program, it's compilation is going smooth, right? Nothing is asked from the user in this terminal. What if we want to ask user that before printing anything, give me my age, right? How to do that? So there is function called scanf, right? So what scanf does is it will ask you what kind of data you want to take. So I want to take decimal point or integer, and I want to make sure that got stored in age, and I have to make sure I put ampersand in front of age. What does that mean? So putting an ampersand is nothing but giving me, like, giving the address to scanf. What does that mean? Let's run this. What is your age will be printed first with a new line, and then I will ask for a input, and until user doesn't give me input, another whole code block will be blocked. So this is what a blocked instruction is. So this is a block instruction which will block runtime of the program. So here I am okay, fine. Now let's gcc compiler is my gcc io a.out. What is your age? Now it will wait forever. Why? Because this scanf has been attached to my terminal to make sure that it will take some input from my user, right? So what is my age? 24, let's suppose. Now it returned to this statement. What is this ampersand? It is nothing but whenever in C you are storing some variable, right? In every language it is like that only. Let's suppose int age. In age you want to store something, but you're telling the program that, hey, allocate some memory to something called age. So what my operating system will do? My operating system will say, okay, ये है आपकी RAM. This is your RAM. I will give 4 bytes to something. I will say, what is something? Tell me कि वो क्या है, how I will point to it. वो बोलेगा, just give me a name. I will say age. So it will provide me, my C program, a memory location that my age can point to. So basically whenever you are saying age is equal to 25, it is nothing but you are storing 25 to your main memory, to your address of that age, which is pointed out to some memory address in your RAM. So yeah, that's what it is. And if you want to extract the value, just print age. If you want to extract the address, now this is RAM 0 to 4 GB. Let's suppose my machine has 4 GB RAM. Now what is this address? I don't know. Addresses are hexadecimal, right? Hexadecimal. What is hexadecimal? Just search. I know that you might have searched binary to decimal, right? Now you can search what is hexadecimal. Hexadecimal is nothing. It's just that now here you have some square, weird looking numbers, 1 2 3 whatever. So this is a address. So what I'm saying to scanf is, bro, I don't know what you want to do. Just take the input from the user of type this decimal, right, or integer. %d is the formatter for that to tell scanf, because if you go inside scanf, it takes a character which takes a character, or I mean format, right? So I'm providing nothing but %d, which is nothing but character array. If you'll think about it, it's kind of character array. Yeah, it's kind of character array, right? What is character star? There is something called pointers. We'll come to that. Don't worry about that. But in scanf, it is just saying that, bro, give me some format and anything. Now anything is my variable, my memory address where I want the user input to get to, right? To go to scanf, redirect format. Now why I am looking into .h file, what is that? That is called header file, right? So in C we have something called header files. When we'll make our project in C++, we'll heavily use HPP or H files, right? So header files are nothing but a template, right, to tell my compiler. What is compiler? Again, I will tell you, but as of now, just think about it as a C program which knows how to convert a C programming language to machine understanding code. Machine understand only 1010, although it converts to assembly language. Don't think about it, it directly converts to something super fancy stuff. But just bear in mind that as of now I'm just talking to that it converts one language to another language, right? It's just an translator, you can say. Now this translator, before running your program, it has to know that from where this printf is coming. You have never defined printf, right? You have never defined printf function here. Where is it coming from? I am saying by include some template, so that you will know there is something called printf. Now what is template, what is function? They are two different things. Now in template, if you will go printf, right? Although there is a definition also, but for some function there you couldn't find any definition. Okay, you would not be able to find any definition. So in header files, what they do is, let's suppose I want to write my own header file, test.h. okay, and what I do is here I only define one function, which is void print. That's it. Now any C programming file can include this test.h, and that doesn't have to tell the compiler what is the definition, what this print will do. Compiler just have to know that there is something called print, right? There is something called print. Test.h. Now if I'll run print, it is, although saying that file test.h void.print, it is suggesting me that the IntelliSense mode of C++. Now I am able to use this print, right? I am able to, there is no error on compilation. Why? Because I am including this test.h. Now this print has no definition, like there is no body. If you'll go, there is no body, although you can give any body, right? You can define anything inside this body, whatever the code you want to write. But even if it is not there, the compiler will still not complain. Why it will not complain is because the compiler always needs what is the function, right? Where it is defined. It just has to know that. It just has to know what is the return type of that function, and that's it, right? So your header files are the template, and those templates are implemented by C files. Now test.c file will implement this, right? Test.h. Now I have to write print, it will automatically detect void. Now here I can define function, whatever I want to define, right? So the people who are coming from TypeScript or Java, they must have known this, that this is an interface, this is a class, or you can treat it as a class which is defining that interface or implementing that interface and giving the definition, right? So that other people can understand that this is an interface. Okay, we are aware about this कि ये कुछ function देता है, but give me the implementation also so that we can run this, right? So header file are nothing but templates. Okay, now I have removed test.h. You will see some squiggles after some time. I just don't want to code. I just copy pasted it from my gist. So basically it's an int age. Type your age. I'm taking age as decimal point and using the address of age. So basically ampersand means address of age, and whatever user is putting, I'm putting that value to the address of age. So basically nothing, but I'm storing that to age. Same GPA. Now GPA is double, so whatever will come from user, it will go as a LF. So floating point with L, you have to make sure that L is there. Only then your floating point or decimal point value will go into GPA as double. Now you can experiment removing L. You can experiment with D only, and while giving D, when it asks for GPA, give it as 2.3. No, not 2.3. Give it as an integer, right? It will work. But when you will give it as 2.3, will it work? Experiment with that, right? Okay. Now here is you want to take name array, right? Character array, and type your name. Here you are saying that I want to take a stream of characters or string, and I'll store in name, and then after taking name you will store print the name, right? but it will not include space if given. What does that mean? Let's see. Type your age. Okay, before that let's make sure it is looking pretty. Okay, there is some warning though, but never mind. My age is 25, your age is 25. So after taking input, this line is printed. My GPA is 2 point, let's suppose not 2.2, 3.8. Your grade is 3.8. okay, what is your name? Lovepreet. My name is Lovepreet. Now what does it mean? It will not include space if it is given. Let's see. Again run. Age is 21, GPA is 44, whatever. Your name Lovepreet Singh. What it will print? Guess, comment, and then resume the video. My name is Lovepreet. It is ignoring the space. Why? Because the behavior of scanf when taking a stream of characters ends whenever you enter a new line or space, right? How to deal with that? How to deal with that is that you have to use something called fgets, right? There is another function for this specific purpose, which is fgets. So if we'll go here, it is a character, basically it returns character, but we don't care about that. Fgets is just that it takes some character array, right? Then it takes the length or n, whatever, and then it takes some file stream. What does that mean? So it is get a new line terminated string of finite length from stream. This function is a possible cancellation point and therefore not marked with throw. Ignore everything, it's coming from stdioh, that is fine. Fgets. Okay, now instead of using this, let's go to this point, right? Fgets, let's use fgets instead of scanf. So here I'll type name, right? Name 20 characters from stream I want to accept, and then stdin. What does stdin stdou out means? What is that? I don't know. Let's experiment. Your age 1, your GPA 42, your name, type your name is. So there is something messing our input. Let's comment everything here. Okay, so it will ask directly for name. Name space. Now it's accepting spaces also. Now it's your job also. You can ask Gemini, ChatGPT, whatsoever, like why with all this uncommented my name is not asking for any input. I'll give you a hint. So basically there is something called stdin, stdout. I will explain you. I am explaining you after this point only that what is stdout or stdin, right? If you'll hover over and go here is, now you'll see that file stdin extern is basically a keyword in C that tells us that this basically stdin can be used in another files also freely. So extern is that keyword, and file, there is a file pointer. What is file pointer? Don't think about it, but I'll tell you. Okay, so what is stdin and stdout? I will explain you, but why without comments it was not working, that you have to figure it out. Okay, the hint is that there is something called stdin, and already the input is lying out there, right? Before coming to this line also, before coming to this line, there is something already in stdin stream that was being picked, some space, or you have to figure that out, right? So now we have three streams: stdin, stdout, standard input output, standard error. I think it's standard only. So maybe I might be wrong. This you have to check if it is 0 or if it is 0. I don't know, but let's say 0, 1, 2. There are three modes, right? So my terminal, whatever I type in terminal, that goes in stream. So basically whatever characters we are typing, our computer only understands 0 1, so it's nothing but a stream of 0 1. Okay, so if I type Lovepreet, it will convert to a stream of characters. Now whenever this characters stream is going to some C program or C file, right, these character points will be typecast, or I will say ki will be treated as character array. Right, now the point here is this, whatever I am typing is the stream called stdi in, and whatever I am typing out or coming out of on, or you are printing on the terminal, whatever is printed here, this is standard output. It works with files. So whatever you type, so stdi in is nothing but a file, a buffer where your input will go. Now this input is being taken by our C program, right, and whatever is printed by our C program is going into a file, and that output is used in as a standard output stream, and this stream only is attached with terminals, or whenever you are playing games, right, your stream is attached with your, so basically your video stream is attached to your screen, where you can see what like visuals you are like getting in the game, right? Okay, let's move on. Now there are something like, we'll cover most of the part, that is more than enough to build projects for our C++ crash course and building some projects in C++, but there might be some things that gets missed, that we'll learn along the way, right? But we will cover more than enough that is there, right, to make your projects. Okay, let's do some revisions. Okay, so this everything you'll get in GitHub, right? Feel free to go through that, but this is the example that is for your revision, right? You have to play around, you have to check what is double. If you'll convert this to float, what will happen, right? What will happen if I'll use the only f, right? So then again here you can check what is here, and there you can use like multiple formatters are here. So this is just a revision file, right? So here it's a comment written that problem is with scanf that it only grabs characters up to space. So if there is at least one space, it will trim all the string after space. It will only pick the characters before space, right? So this file you can check. Now let's move on to arrays. Okay, so let's move on to arrays. Okay, so let me define even numbers array, and again array is a contiguous memory block that is assigned for integers. So if there are 10 integers, mean 10 into 4 bytes, 40 bytes will be assigned. And how I can assign array is 2 4 6 10 12. So I think these are 5 numbers only, but there is a space of 10 numbers though, right? So in integer I don't think there is any null character like in char array. There is null character to terminate your string, right? So if you have 10 characters, let's say, and you are storing only 5, then your null character will come at the end after the 5th character, and you will only be able to print those 5 characters. But I don't know in int array what we can do, right? So let's see how to access any array is through indexing. And I told you that indexing start from 0 based indexing, 0th index, 1st index, 2nd index, 3rd index, 4th index, right? Okay, now let's print even numbers, 1st index, what will come, just you can comment. Okay, so nothing will come out, right? Segmentation fault. Though segmentation fault is that you are trying to access something which is not actually you are supposed to do. So now let's see now what will happen. 4 is coming here, right? Let's put some null line, a new line, so that you will be able to understand 4, right? So 4 is at first index. So I have stored 5 characters. Let's suppose I want to access the 6th one. So 6th means 0 based indexing, 5th correct, the data type, the character which is stored at 5th location, right? Now let's see, it's giving me 0. Now let's see, it's giving me 0. See, 0. Let me check 6th character. Okay, it's giving me 0, right? So I haven't stored anything, but it's still giving me character, means there are some characters already existing there, right? But yeah, you have given 10, placeholders, so it will store, it will have 10 blocks of integer to store, right? So again, that's it. What if I want to redefine at 4? I want to define a number which is 18, right? So what I'll do is I'll do even numbers, pick second number and make it 18, right? And now let's print second number and 18 will be there. So that's how you replace numbers, right? And this is the syntax is pretty simple. You have array, you have index, you have new data type or new variable, no data type. Okay, this is the syntax for assigning the variable in place. So it is called in place. Why? Because I am not reassigning it. Like I am not saying key after assigning, right, after assigning it will give me another array. No, in the array, in the address itself, it will go and store 18 here, right? I don't have to reassign anything, and that's what we call as in place replacement. Okay, fine, that's it, right? So that is it. Let's do one more thing, which is character name array, printf. Now this is array again. This is kind of list only, nothing fancy, just that it is storing characters only, right? Not integers. So my name is stream of characters, name, printf is giving me something. Okay, my name is Lovepreet Singh, right? It's simple. Now if I want to print character at first place, what it will print, just tell me in the comment section. Okay, it's printing O is the character here, right? That's it about characters. So quickly I will cover functions, right? I'm pasting the code here so that I don't have to code everything. So here I have commented also for you. You can go through the example in GitHub code. So declaring a function, below the function which is calling declaration versus initialization, return type. So there is two things, right? One is declaration or initialization, second is return types, right? So I am here saying say hello. I'm not giving any declaration, right? I'm just defining a function name. I'm not giving any body. I've just said there is a function. So compiler, how it goes, it will first come here. It will see, okay, I have to include all the template in stdlib.h. I will include that. I have to include everything from stdio.h. I will include that. There is a function. I'll keep in mind there is a function of name say hello. It is used. Now compiler will say, okay. Now let's start the compilation, or let's run the program. So now when program will run, its main entry point will be the main function, right? So it will go into the main function. It will say, okay, I have to call say hello. I have seen it say hello, so I can't give any error because say hello is defined. But where is it initialized? Where is the body of say hello? Then it will try to find in entire file. Here it will find say hello program. So say by function is there. I am passing a argument Lovepreet Singh. So say by is nothing but a character name array, right? This is name array, right? And then cube. So cube is nothing but so 2 to the power 3, 4 to the power 3. That's what number into number into number is nothing but number to the power 3. So I'm storing it in as double, right? Returning the result. That's it. That's it about functions, right? There is one more thing which is pass by reference, pass by value. So let's take an example of that also. Int reassign value, int a return 54. Okay, now let's say int a is equals to 10. Okay, reassign value 10, and I am storing that to b and printing the value of a. Okay, so I'm printing the value of a and b. Let's see what happens. So value of a is 10 and value of b. Value of a is 10. I'll call the reassign value. What it will do, it will return 54, and this 54 will be saved into the b, and this b placeholder is print after that, right? Let's suppose what I do here is I do this thing. Got it? And now let's run this. So basically, okay, before that let's do normal thing only. What is it telling here is key a value is 10, b value is 54. Why? Because when I called reassign value with a, right, it is passed by value. So there is new variable which is created, a variable for this function, which is called local variable. This local variable is reassigned to 51, right, and then 54 is returned. So a, which is local variable to this function, is reassigned, and this dude is not aware about that. This dude just say I passed something, and that something I have given to that function. I don't know about that, right? So whatever it is assigned to in that function, it doesn't hamper this value. So that's why still a is coming as 10, and although b is coming as 54 because the return value is assigned to b. Now if I pass it by reference, it means now I am passing the address of a, not a. So I am now passing the address, which means this a. Now what I've done here is I've done something star something ampersand a. What does that mean? So whenever you put a star, that is called pointer. What is the pointer is key. So basically a pointer is nothing but there is an address, right? Now what will happen is, let's suppose I have some address 421 and it is storing 56, right? So my value, let's suppose, is storing 56. Now I want to make sure a pointer to this 56, and let's suppose I am naming that pointer as ptr, and I have to make sure that in C I have to tell it that use star, right? So it tells compiler that this is a pointer to something, and this is a pointer to address of value, right? So pointer will store some value, not ptr. It will store some value, basically the address of value, whatever the address is, 0x421. So this pointer is nothing but pointing to a value, right? So whatever I will change using this pointer will eventually get changed to this address. That's how it works. So when I am reassigning value, I'm actually accepting a pointer. I'm making up a pointer in the parameter of reassign value, and that pointer is holding the value of a address, right? So basically it's nothing but it's making sure that this is a pointer is storing the address of a, right? Or if I'll say this a, and here I will say a. So now okay, so now this a is the value. This value stored in on memory with some address. I have extracted that address with ampersand, and that address I have stored in another variable which is a pointer, right? So this is nothing but there is something called a storing 56, and when I'm calling some function, I'm making sure that some pointer is created, local pointer created for that function, and that is storing this address, right? now there is something called free the pointer, delete the pointer, something called that. We'll come to that. But now I want to make sure that whatever this pointer is pointing to, whatever this pointer is pointing to, right, I want to change its value. So that's when I have to dereference. If I'll only say a is equal to 51, it will just say whatever the pointer is storing, make it to 51. Pointer is storing the address of someone. So what I want to do, I want to go to that address and change the value of that address which it is holding. That's where pointer dereferencing come. So basically we will create a pointers file also, where we'll basically explain you in detail, but in a nutshell, so this is how you can dereference a pointer. So star a is nothing but this value. When you call a means this value, star a means this value, right, this address value. So that address value I am changing it to 51, right, which was earlier as 10. That's why when you will run this, it will come as 51. Cool. Now there is something called conditionals. Now we'll not spend too much time on this. So there is something called the syntax I will give you. If condition, okay, else if condition, and else. What does that mean is condition can come to true and false. So true and false data type is boolean, right? So like int, I can call boolean a is equal to true. So like integer double, there is another data type called bool. So there are many other data types which are used, right? There are like that you can explore on your, on your own. So there is something called short, there is something called byte, there is something called boolean, right? Boolean is nothing but true false, right? So when this max function, right, this max function is calculating the maximum number out of 3 numbers. What is it doing is, it is first defining an integer result, storing nothing. So it will store some garbage value, right? Because in C program, whenever we define a value result, declare a value, right, we are telling compiler that when you will come at this point, make sure that when the programming is running, make sure that like during compilation, not the runtime. So whenever you are compiling, make sure the compiler will take this account that before running this function, you have to make a 4 byte ka space for result, right? Then after that 4 bytes will be used to store something, and those 4 bytes or result will only be returned. So the conditionals are not equal to, more than equal to, less than equal to, more than, less than, or, and. That's it. So if number 1 is greater, it should be greater than or equal to number 2, and it should be greater than equal to number 3. So this is greater than or equal to, like it can be greater than. If number 3 is 4, so if number 1 is 4, number 3 is 1, so 4 is greater than 1. If number 1 is 3, number 3 is 3, it is equal. So either one of the condition can happen, either it is greater than or equal to. So this can come as true. Number 1 is maximum. If it is greater than 2 also, it should also get true, and true is true. So this is fine. Similar as this for number 2. If number 2 is not maximum, number 1 is not maximum, who is left? Number 3. That will go in else case. So it will check if condition is true, nahi, आगे बढ़ो. If this condition is true, नहीं, आगे बढ़ो. ये तो हमेशा चलेगा ही. So number 3 is the base case which will always come if number 2 and number 1 are not maximum. Obviously number 3 ही maximum होगा. So that are the conditionals, right? Switch statement फटाफट बता देता हूँ मैं आपको. So again, I don't want to code this, I'll just explain you because जो explain मैंने पहले किया बेसिक्स, उसके बाद I think इतना तो आपको पता चल ही गया होगा because we are only using printf. So अगर मैं switch case ना यूज़ करूँ, मेरे को किसी को बताना है grades, तो मैं बोलूँगा grade अगर मेरे को A आया है तो print कर दो ये, ठीक है. else if अगर मेरे को grade B आया है तो प्रिंट कर दो कि भाई तुमने ठीक ठाक ही किया है, ठीक है. और सीधा सारे केस स्किप करते हैं और डिफ़ॉल्ट केस लिखते हैं कि भाई अगर कुछ भी नहीं आया तो तुम फेल हो, ठीक है। तो इतने इफ एल्स लिखने के अलावा कुछ कीवर्ड्स हैं। स्विच केस क्या करता है, सिंटैक्स ये होता है कि स्विच टेक्स वन थिंग, राइट, ग्रेड, and it makes sure that case A, it is nothing but it is checking grade is equals to A, right? Here it is checking nothing but grade is equals to B. So यही है if else. So if this is the if, this is the else if, this is the else if, this is the else, right? So at every if there is only one extra thing that you have to do in switch case, which is to provide a break statement. If you will not provide a break, this case will run, and then next case will also check, then next case will also check, and default will also run. It will not break to the one case, right? You have to check, you always have to give break. That's it. Okay, now the main things come, which is struct. Till this point we discussed like arrays, we discussed about data types, right? So some of the folks might have noticed that in array, okay, my battery is exhausted, my camera battery is gone, fine, no worries. Okay, some of you folks might have noticed that in arrays we are not able to store integer at one place, character at next place, then let's suppose string at another place. We can only store data of same type. Like if array is holding integer, it will hold all the integers. If it is holding character, it will hold all the characters, right? Like ABC and null character array के अंदर होता है, right? But if I want to make sure that there is a student, right? अगर मेरे पास एक student है who has character name, right, who has integer age, how to do that? Because no inbuilt data structure allow me to do that in C. So that's where structs came, right? Struct is nothing but again a data type only, right? So you can define a student of name, which major he is doing, what is his age, what is his GPA. Struct is a data structure that can hold different data types, and that's it. Treat this struct student as a data type only. Like जैसे आप integer लिखते थे वैसे struct student लिखो, जैसे डबल लिखते थे वैसे वो करो. The way you were used to make integer array, use that form only, and use in the same way, use structs in the same way, right? So here instead of making it int student, I am making it as struct student. If someone says that struct student, always I have to make sure that, let's suppose I have to make array of students, right? What I will do is struct students array, 10 array, 10 element it can hold, right? But now what it is doing is incomplete struct student 10 is not allowed. Why? Because I am just giving it the size 10, which is not allowed. So I have to do something called malloc though, right? That will come to later part. But now the only difference here is that if you are using student 1, right, now to okay, let's remove this. Now to this student 1, let's suppose this is me only, my age is 22, my GPA is 3.2. I can assign the variables that are there in struct using this dot notation, right? But how to assign character array, we can't do this. We can't say that student 1 dot name we can't do that. This is how it is, right? So we have to use something called string copy, right? What you have to do is use strcpy function, tell him like what you want to store, where you want to store student 1 dot name, you want to store csc, where you want to store student 1 dot major. Let's run this. Okay, nothing has been printed because I have not printed anything. my name is Lopri Singh, right? So that's what structs is. You don't have to worry. The only thing that people can say is कि हर जगह हमें struct लिखना पड़ेगा, struct student instead of just short forms like int. Like जैसे we have to write unsigned int, like it's too much, right? How can I shorten this thing? Like struct, right? So you can just use type def. Type def is nothing but defining a type, right? Type def this too, or student struct, right? Now wherever I want to use this, I'll remove this. Now hover to this. What it is doing is, it will define this struct student as ss, right? Similarly, you can define the type unsigned int as uint. Okay. Similarly, there is something called long integer, this, right? So wherever, let's suppose you want to store my let's say any big number, you can say big number whatever, right? So that's how long, and these are another data type if you people have not noticed, right? So long is just that this integer will be 8 bytes, right, instead of 4 bytes. So how much the largest number 8 byte can store, you can calculate. Okay, fine. Now we covered arrays, let's cover 2D arrays. Okay, 2D arrays are nothing but two-dimensional matrices, right? Matrices only. So 2D array is nothing but, let's suppose this is your array, right? Your normal array was this, where you used to store some elements. 2D arrays are nothing but you store 2D elements, right? So this is nothing but defining a 4x4 matrix, right? 4 rows, 4 columns, or chessboard, right? So how you will do it? Eventually a 2D array is nothing but a combination of 4 arrays. First array, right? First 1D array, second 1D array, third 1D array, fourth 1D array. So 4 1D arrays are stored to make a 2D array. That's what we are doing. Instead of defining it a 1 array, we are defining it as 5 2. So 5 2, what does 5 2 means is, so syntax here is very simple. Whenever you are making an array, int array, and if it is a 2D array, just tell him what the rows are, what the columns are, how many columns you can store, how many rows you can store. That's the syntax, right? So basically these rows are nothing but this rows 0 1 2 3. So whenever someone is saying array 0 2, it means go to 0th row, second column, so this point. If it is saying 2 3, go to second row, third point, this one, right? It just simply mean is, right, go to second array, first array, second, like 0th array, first array, second array, 0 2, go to second array or second index, pick third column. Okay, so that's it. So 5 rows I am defining, 1 2 3 4 5, and every row has 2 columns, 2 2 2 2 2. Okay, so you can see number at ith row, jth column is, so here number at second row, second column is 2 2, right? So the syntax is number at ith row, jth column is equal to num I j. Okay, something like this. So now comes the part which is loop. Loop is nothing but, so basically when I will say to you that print every number of this array, what you will do, you will first print, you will call this go to first row, first column, then again printf, and you will print this, go to first row, second column, and similarly third column, similarly fourth column, and then you will go to first row, 0th column, first column, second column, third column. So printf will pile up like crazy. Okay, so instead of that, to repeat something, you use loops. So loop syntax is very similar, like very simple. For loop, here you say starting point, where you want to start from. Here you say condition which should go false at some time. Here you say change in condition, which will change the condition, because if your condition is not changing at every loop, how this condition will stop, right? So this is the syntax. So here what I'm doing is starting point of my integer, any temp integer is 0th. I will keep on like looping until my I is less than 5. So this is a condition, I is less than 5, true, I is less than 5, true. When I becomes 5, it will get false and my loop will stop. I plus plus is nothing but incrementing the ith number and jth, right? So this is how you print the array. Okay, memory address or pointers, I can say, right? Now this is also simple, right? I've already explained you age is 40. So the int container has some 4 bytes of size, where it is storing 40 as a number. And now you want to make sure that you generate a pointer which points to age. So you generate a age pointer. So you have to make sure that this is a pointer, so that you can tell compiler by using star, right? So after using star, you have to also tell that what is the type of pointer which it is pointing to. So the type of pointer, it is int, and this pointer will store age ka address. So this is what we are talking about. Let's talk it about again. So pointer is nothing but you defined age on your memory. There is 4 bytes assigned and you are storing age 26. Now you want to make a pointer age star, right? I think that is the pointer, age pointer, sorry. You can't do it with same name. It is nothing but it is storing some address of this, which essentially means it is pointing to this address, right? Now wherever, in whichever function I will send this pointer, it will always point to this address, and whatever the function it is used in, if that function is changing the value of this pointer, it will change the value everywhere wherever the age is used, right? So you can pointer the address of a pointer using a p formatter. Like if I'll run this, okay, segmentation fault also will discuss. So address of age is, so this is a hexadecimal value. So address of age we got, right? Then GPA, I made GPA pointer. Grade, I made grade pointer, right? So here you can see definition pointer is just a memory address, nothing else. Don't treat it as a fancy data type. It is just a memory address. It is just another type of data, right? What is pointer plus one? Although that I also will discuss, right? So here I would noted that we also have to discuss 2D array pointers, and we'll discuss that. How you can dereference, I've already explained that whatever the age pointer is pointing to, if you want to print that, dereference it using this star again. You're not defining it. If you are defining it, you also give data type, right? You also give data type. But here when you're dereferencing it, there is no data type. So it will return whatever it is pointing to. So this is ND pointer array. So this is quite complex. You can ask LLM also, but what we are doing here is we are creating an array. We are creating an array, right? But this array is using double pointers, and this is the problem, right? This is a problem. So let's suppose I remove everything. Okay, I've commented everything, only made one function, and that function is called in main function. Now I'm getting segmentation fault. Why? See, this is not a correct way to define any pointer towards an 2D array. Okay, what I'm doing here is I'm just saying that there are 2D pointer, like a pointer which is pointing to a pointer. 2D pointer is nothing but, see, so there is a value, let's suppose age. There is a pointer, let's suppose age pointer, which is storing the address of age, and this pointer itself is stored at, let's suppose, this address. There is another pointer 0x425. So basically it's nothing but int star age pointer. So age pointer is pointing to another pointer, so that's where double star is used. So what I'm have to do is age pointer, right? What age pointer is? Age pointer, this is age pointer 1 is equals to age. So what is happening is ki first I'm making a age pointer which is using age ka address, and then I'm making a double pointer which is storing the age pointers address itself in age pointer 1, right? So this is what double pointer is. But in array, if you will see how you will define an pointer to 2D array. So first of all, you have to define an array, right? A list which will store something like this for array. Now you want to make sure you want to store pointers. So basically this array is pointed out by, let's suppose, array 1 pointer star, array 2 star. Yes, we can point a array by pointer, because why? Because arrays are nothing but a contiguous memory block. So whatever array you are allotting, let's suppose I'm allotting an array int 4, so it just means 32 bytes. 16 bytes. An int is of 4 bytes, then 4 integer if I'm allotting, it is just that for 16 bytes I'm allotting this size. So let's suppose the first array element starts as 0x426. So if I'm making like array like this, int star array 5, let's say, so it just mean that array, there is a created array of 5 elements, but ARR is a pointer towards this array, and it points to the first element of the array. So basically ARR pointer will be first element of array. So first element, second, third, fourth, fifth. So if there are 5 elements and there is a pointer ARR star, this star will do nothing but this 5 block of integer which are stored in memory. It will point to the first, whatever the first element is, uska address, which is nothing but this. So pointer arithmetic is nothing but, let's suppose you are defining an array, right? So array plus 1 is nothing but you are like adding plus 1 address into array pointer. So what does that mean is ki if my address first my address is 0x426, my first element address. Now the second element will be at 4 bytes ahead. Let's suppose address starts as not 0x426 but 0 itself. Okay, let's take that simple example. Okay, so let's suppose this address is 0. Now the next address will be 0x whatever 00 in decimal, let's take 04, or I think 0x0 10 012, something like this. So 0 plus 1, so basically whatever the array was pointing to, it always points to the address of first element. Plus 1 is nothing but it will add 4 bytes because this array is holding integer. So plus 1 is not actual the plus 1 in the address, it is actually plus 1 size of a integer, right? So it will add 4 bytes. So eventually array plus 1 take you to the next element. Okay, so if it is a character array, okay, so now if I'll add name plus 1, it will add 2 bytes actually to the address of name. Okay, and address of name is nothing like the pointer name is nothing but the address of first element of array, this array. So that's what called pointer arithmetic. So whenever you are adding or subtracting, you are just adding or subtracting the equivalent bytes of the array data type, whatever you are stored in array, which that pointer is pointing to. Cool. Now why the segmentation fault here is coming is because this is a wrong initialization. We can't initialize it. We can't initialize a 2D array using pointers like this, right? We can, but how? We will look at it. Don't worry. Okay, so let's now take some more, memory management stuff. So there are basically 3 calls, right? One is calloc, one is malloc, one is realloc. Calloc is nothing but allocate memory. Malloc is nothing but again allocate dynamic memory. So and realloc is reallocate the memory, and free is nothing but to free the memory, right? These are the 4 functions for dynamic memory allocation. What does dynamic memory allocation means? So basically whenever you write a C program, right, you use compiler called GCC in Linux, and you convert this into an object file, and this object file is giving it to assembler, right? We'll give this object file to assembler, and then something called linker and all will come, that will discuss, don't worry. And finally machine code file will be made, that is understandable by the computer, right? But the problem here is when you are converting this object file, and when this is called compilation, when you are just going through the project structure, you are checking the syntax, if syntax is correct or not. You are just checking if function is defined correctly, if there is no division by 0 error or something, that can be find out at compilation only. There is no need to run the program. So that is called compilation. When you are running the program, when your machine code is generated and your machine code is loaded into the RAM, your main memory, and that code is taking some CPU also, like when it is taking some resources and running the code, then it is runtime, like when code is running, right? So when we do this during compilation only, a C program knows that I have to allocate 5 into size of integer, which is 5 into 4, 20 bytes to this program, and assign this to ARR, or if it is int A, assign this to A. Okay, but there is something called dynamic memory allocation, which is runtime memory allocation, right? Which compiler is not aware of. That's what we call dynamic memory allocation. So its syntax is, you tell the pointer, okay, whatever the memory will be allocated, there will be a pointer given by this function, and that pointer will point to that memory allocation. There is one typecasting, like you have to tell whatever the return type of this malloc, convert that return type to this kind of pointer, and in like inbuilt type conversion of C will be used, right? Now you are using malloc memory allocation. How much memory you are allocating? 4 elements into size of int. So basically you are doing nothing but you are making an equivalent like this, right? When we do this, like without dynamic memory allocation, compiler already understand 4 in, like it has to allocate 4 into size of int. This picks from here. But when you use malloc, it has to be like given the exact bytes. So that's why you have to give the exact bytes, and this pointer will be used. And if there is no memory allocation, like you have less memory, or you are all the processes are running and your memory is not, like no memory is left, then you will get nothing. So null pointer is there. I think even you can make, okay, in C++ you can use null pointer, but here you have to use null only. And exit is something called, if you will go into exit, so it is so here you can see it's a header library. There is no definition now, you can see, right? It's just a, like the signature of method is given, like it will return void, right? Extern is given, like basically you can use this function anywhere in another file. It will accept some status, and then it will throw something. So throw is nothing but a compiler specific keyword which will throw something, and you can read what it does, right? So basically it will panic the program, it will stop the program entirely. But if pointer is made, now what you can do is you can store the pointer value. Now what is happening is you have, okay, let me visualize you this. So you have done this typecast pointer malloc 20. So basically 4 into size of integer is 20. So you have done nothing but a 20 size array you have allocated. So 4 elements, 5 elements basically, right? It is pointed out by pointer. This address is, let's suppose 0x001. This address is 0x00 plus 4 bytes you have to do. Decimals में ले लेते हैं यार, it will get me confused also. This address is 4, 8, 12, 16, 20, and address, it will store first element address 4. Now what I am doing here is, first I am running a for loop, I is equal to 0, pointer plus 0 is nothing but a pointer. So I am storing, I am dereferencing that, and I am storing there. So dereference means nothing. I am not using pointer value here. I am going to the pointer value and dereferencing that. Basically I am talking about this value, not this address value. Whatever is stored at the address place I am talking about, not about the address. So I am storing different value I. So I is 0, I will store I 0 here. When I is equal to 1, 4 plus 1 means 4 plus size of int 8. So I will come here, store 1, 2, 3, 4. This is what pointer arithmetic is. Pointer plus 2 actually means, pointer plus 2 actually means whatever the pointer was plus 2 into size of int. ठीक है, so that is what pointer reference is. Now this was malloc. Now you can use calloc here also, right? Now the difference between malloc and calloc is nothing but only small one. What is it doing is, okay, let me check what calloc does. Size and okay, yeah. So size allocate elements of size bytes each. Okay, the syntax of calloc is cast and n is the size, element size. Okay, so we are using it wrong actually. We want 4 size and size of character. Okay, this is the different syntax actually. I think even then it will run fine. Yeah, okay. So we are doing nothing, bro. We are just dereferencing and storing some points, and then we're just using, pointer arithmetic and dereferencing that address. So ptr1 plus I, what it will do, it will add some bytes to it, and then that address is being dereferenced. Now realloc is nothing but, realloc is used when you want to reallocate more memory. So let's suppose ptr1 in whenever you are running your function. so you need more memory, right, for ptr1. So you will say ptr1 give me this much amount of memory more. So let's suppose earlier you have 40 bytes. Okay, now it will add 10 more bytes, 10 into size of character, 10 more bytes, and these 40 bytes, whatever they were storing, like the characters, they will be there, they will not get replaced, but the new memory will come, right? That's what pointer is. Now whenever you make pointers, they are made in heap. So these all pointers, these pointers are made in stack, these are in heap. Heap is nothing but a dynamic memory which will not get freed automatically. What does that mean is, we'll talk about it, but essentially it means is, whenever your function exit, whenever your program exit, this heap will not get automatically flushed, right? In Java and all, it will get automatically flushed using garbage collection, but in C++ there is nothing called garbage collection. So even if this pointer goes out of scope, let's suppose this main function completed, my program completed, returned, everything is done, but this memory allocation, who will flush this memory, right? That is the question. So we have something free also, a function there, right, that you have to call basically, and you have to free everything, right? This, so it will see what ptr1 referenced, right, and it will delete everything. So now realloc, malloc, calloc, why they are called dynamic memory allocators? Because see, now during compilation, when I am just using this gcc, right, it just know that in future this program will take some memory, but it is not pre-known that how much memory it can take, because see, we can use realloc later on. Nobody knows. I can put even a condition here, right? If let's suppose time, I am using time library, if agar 12 baj rahe hain, then reallocate memory to 20 bytes. If it is not 12, then reallocate to 10 bytes. So compiler is not intelligent enough to find it out. So that's why when your program will run on the runtime, not compilation, then this realloc, malloc will allocate memory. That's why they are called dynamic memory allocation or runtime memory allocation. Now this is the way how you can define 2D arrays, right? This is one of the way, right? So what you are doing here is, first I have already told you that 2D array is nothing but storing pointers. Okay, where I have told you, yeah, 2D array, अगर मैं इसको simple terms में लिखूं, what a 2D array is, let's suppose this array, 2D array, what is this is, इसको थोड़ा सोचो बैठ के, think about it with clear mind, that 2D pointer which is pointing to 2D array is nothing but an array of pointers. So first I have to make sure that I can make multiple pointers, right? Then only I can make 2D pointer array, right? So what I have done here is, I have made a pointer data, right, which is holding 4 integers, right? It's a pointer, data is a pointer which is pointing to an array of 4 integers. Now array 2D is a pointer towards 2D array which is pointing to 4 integers, no, 4 pointer towards integers. So it is complex. So this is your homework actually, to understand what 2D pointer is, right? You can ask LLM, you can visualize, you can draw on notebook, and you will know about it. Got it? Last thing is file io.c, then we'll go towards Makefile. So in C, these are example I noted down, but anyways, in C there is something called a standard library, right? Let's see from where this file is coming up. File io, file defined, if not defined, okay, it's not it's just file.h, I think. Okay, it's not even a file h, fine. I think in stdioh or maybe, yeah, fine. So basically file is nothing. Okay, it's just a pointer again, right? So file is nothing but a location where a pointer is. So you will get a file pointer always, file pointer, which will point to a file. So basically I don't want to go in detail, but there is something called inodes in file management system. So inodes are nothing but integer values which they store, then they point to files. So file pointer is nothing but you can use f open, file open. You can open the file, whatever file you want, right? If this test.txt doesn't exist and you want to read it, then you will get an error that file doesn't exist. But if you do in write mode, then if file doesn't exist, then when I will run our program, it will create the file first. Then what you can do is you can use fprintf. So there is a special function fprintf which takes file pointer, right, and which takes what method you want to what output you want to print. So take pointer, use I'm a disco dancer, and close this. So what it will do is it will print the content into the file, right? Let me run it. So there is nothing printed out because I have to make sure this removes. Okay, I'm a disco dancer, right? So what is happening here is ki I have pointer, I'm using that pointer, passing that pointer to here, this function, and I'm writing something using that pointer, right? And then I'm closing the file. That's it. That's all what I'm doing, right? So there is another you can explore, like when you want to read, when you want to append, like when I want to append, right? Let's run this again. So now I am a disco dancer is appended at the pre-written text. So that's what will happen when you use append mode, right? The restrict mode here is append, earlier it was write. So let's use write again. So now a fresh file is created and written, the text is written there, right? So that's it about all the basics of C, right? Now most of the people might feel overwhelmed already by these concepts, right? But don't worry, we will, after covering C++, when you will make your own projects, when you will write your own Makefile, C Makefile, you will come to know that how to structure a project carefully, how to build them, how to code. You will know that. But now this was the prerequisite. So now the next thing is to introduce you something called Makefile. So now let me tell you, like whenever we build projects in C, right, C++, your folder structure will keep on increasing, right? So let's suppose this is src folder. There one thing called pthread, let's suppose process.h. There is something called process.p, right? So h file is nothing but a template. All the functionality defined here will be implemented here. Main.c, right? Now I want this main.c file is using process.h file, right? Now whenever I want to run my main.c program, it has to know the exact location of this process.h, right? So let's suppose my directory structure is like this. In src I have process.c, I have process.h files, but out of directory I have main.c file. So I have, like whenever I am using process.h or process.c files in my main.c, whenever I am compiling, I have to tell the compiler where my header files are, right? So let's suppose this process.h, this is using some pre-defined library. Let's suppose a threading library is there, which is pthread, right? Not pthread but thread.h library. That might be on my system. This library might be on my system, right? But my compiler might not be able to find that. That is one thing. Another thing is, let's suppose there is an object file, like whenever we were making our files, we were making a.out. You can make them object file also, like a.o. Now you can run those a.o files also, right? And it will still run, right? So whenever your program needs header file, you have to tell the program, right? This is your project. It needs some outer libraries that are on your system, but how your compiler knows, right? So first one is this. Second one is there are some dependencies in your project that you want to include. There are some directories that your compiler are not aware of, right? So all these things. Another thing is your project needs some pre-executable thread.o. Then there is something called linker, where your project needs to link some object files to your current main.c so that it can use functionality out of the object file, right? So that is where Makefile comes into the picture. So basically, let's suppose my main.c file is calling some function of this object file. So what linker will do, it has to link this thread.o library no main.c. Now this is a fairly simple example. Let's say आपका project grow होता है और बहुत बड़ा project बन जाता है, right? Let's suppose there are very couple of files, right? Now there are many files which needs different libraries, and your main function also, main program also needs some libraries. Then what will happen? How will you run those programs? So there is what we use called Makefile, which is a build system, right? So if you are using Windows, you will have nmake, right? If you are using Linux, you will have Makefile, but the popular one is Makefile only, right? Now let's in Makefile, let's create here main.c. Okay, so this is my file, include IO stream. Okay, now I want to compile this file, right? How I will do this? So that is the question, right? So before going to Makefile stuff, let's talk about C program compilation. Okay, let me bring okay, so it's a fairly simple compilation. Whenever you write your C program first.c, your PC doesn't understand. Okay, int main printf, your system doesn't understand. So whenever you do compilation, first of all, there is called pre-processing. So let's suppose you are using something called include, right? You are using type def, so you are using some shortcuts where you want to minimize your written code, where you have to write less. So those kind of pre-processing or some kind of early compilation errors, everything. Then this file will be generated expanded code, right? All the code will be, whatever you are trying to include will be included, and the main code will be there in this file. Now compiler is another program written for C, which makes sure that your program is able to compile. There is no anomaly, there is no ambiguity. Your program will run just as fine. If it is running as fine, it will generate some assembly code. What is assembly code here is, let's suppose now I'll give you a fairly simple example. Let's suppose you are doing this. You are adding a 10 in A and reassigning the value to A. In assembly code, it will be like this. Now let's suppose there is a register Z, which is storing A, the register B, which is storing 10. So there will be first of all add basically Z B into C, then move C into R. So something like that, right? So assembly code is nothing but a set of instruction, 1 1 2 2 3 3 word instruction, which uses symbols only, like move, add, jump, right? So they use register, something called register, which is a hardware component, right? You have your CPU, you have registers, hardware component which can store small memory, but they are extremely fast, right? So assembly is nothing but it uses all these registers, CPU, memory, and it makes your code like printf everything into a simple words, so that this code can simply be converted to machine code line by line, right? And this code only will be, will go through your CPU gates and all, and will run in your memory, and eventually the result will be printed out on your CLI or whatever, right? So before this assembler, I have told you like this thread.o library might, like some function you might require from another object code, right? This object file. So before that there is a linker. So whatever you want to make an executable file of this first.c. Before going any further, your assembler will give the code to your assembler will generate the code, and your linker will be responsible of attaching any object file code needed to your file.c code, and then final execution will be done. Okay, so that's what Makefile makes easy for us. Let's go through Makefile. Fine. So Makefile syntax is very similar. You have target, you have prerequisite, okay, and you have command. This is a syntax. What it will do is, let me tell you. So let's suppose I want to make a target of main, not main, let's suppose test. There is no prerequisite, let's say, and it will run gcc main.c test. ठीक है. Make sure you install make. If you do not have make sure you sudo get apt install make whatever in your system. After you install make, then you will be able to use make. So in this directory, I'm at this directory which has the make file, which has the main.c file. Ignore every other folder. In project, when we'll build our project, our make files will get so complex that you will be able to understand, because now you have done your C programming prerequisite course, right? Okay, so now when I will use make, it will do something like this, and it has generated some test file. Let's run test file. Hello world. Yeah. So I given this as a target, like you have to run this target test, right? Now let's suppose test 1. Let's run test. Okay, let's delete test first. It generated nothing. Okay, it generated test file. Why didn't it generate test 1? Because by default make will check there are 2 targets. Okay, it will only pick first. Okay, it will only pick first. It will pick test target. It will run this command and it will generate output file test. What if I say कि before running test, your prerequisite is to run test 1. Now let's make. Now it will generate test 1. Now it will generate test 1 test also, because this is a target I want to achieve. By default make will come here. It will run this target. If there are multiple targets, it will not run, but there is a prerequisite. So that prerequisite has to be fulfilled first. So it will go here. It will run this command first. It will generate test 1. Then it will come here that your prerequisite is satisfied. Then I will say, okay, now run this command. Okay. So this is the first syntax of Makefile. Now, yeah, that is it. Now let's take another example. Now we'll try to mix some blah o main dot o. Okay, let's take blah o. Let's make it blah. Okay, now this has prerequisite, so I have to define some prerequisite command also. So this is the syntax. So one thing to notice here is don't give 4 spaces. In Makefile you have to give tabs. Okay, make sure you know that. Okay, so I've just echo. So basically in shell programming, echo is nothing but to print, right? So what I've done is I want to build a blah target, right? Now this blah target is dependent on blah.o. It can be blah.o, it can be blah.y, whatever, or blah only, right? But it will be recursive, so I will not make it blah. I'll make it as blah.o. Now it will try to build this target. Now this target again depends on blah.c. It will go here. So it will first print this. After that it will come here. It will run this blah.o. It will come here. Now it will run this. Okay. Okay, cannot use executable file as an input to link. Okay. What does that mean? Okay, blah.o I have to drive. Okay, so forget it, but let me define something. Okay, so yeah, so let's come back to the point. So yeah, that's how it is working, right? So now let's take our example to variables, right? So let's suppose I have files, right? So this is how you assign a variable, though you can use equal only, but this is a better practice to use, right? Let's suppose I'm making it 2 files, right? And there is some file. So this is a target for Makefile, right? So now this is how I can use variables, right? So again, enter tab, echo making files, right? Okay, so what it will do, see, first of all it is saying that files variable is given to file1 file2, right? Now this file1 file2 variable is files. Now when I'm defining a target, its prerequisites are file1 and file2, right? And this is just a command which will print making files and just a variable. This is how that syntax is, right? So now this prerequisite have to be fulfilled. So first prerequisite file1. Okay, I will create touch. So basically touch is a terminal command. If I'll go here, touch test and enter, it will generate test file, right? Okay, touch file1 or whatever you can create, right? Filex. It is just that if your first target is dependent on something, then those prerequisite has to be fulfilled, right? Flex. right? And there is one more clean command that I have to define. Okay, so I'll run make. So what it is doing is it made two files, filex, flex, right? Two files, and it had made some more file, maybe some file, right? But it has not made that. So I've defined some clean command also, right? What it will do is it will run a Linux command, right? CLA command, remove recursively, forcefully these files if it exists. So now make. Now if I'll run make, it will by default take this target and it will again run, right? Again run, making files, whatever, clear. Now make, I have to give it a target, clean has no dependency, no prerequisite, so it will run straight away. So it will run this command and it will remove filex, everything, right? Okay, yeah, that was like one thing, right? You can take this template as a generic template though. This is a template, a very simple template where you have target, like not a target, but yeah, one target which depends on these three prerequisite. These prerequisites are defined like this, like they are itself, the prerequisites itself are target only. Okay, so let's suppose you have a target which is dependent on main.c, main.o, right? So I am first talking about the syntax, then we'll take an example. So in make files, whenever you try to use this, right, this means this refers to the target. This symbol refers to the target, which is all, right? When you use this refers to first prerequisite, which is main.c, first prerequisite. Remember this means to all prerequisite. Okay, so these are special symbols for Makefile, these three. So there is one target here which depends on 1, 2. There is these prerequisites are defined as targets here, 1, 2, right? So 1 creates nothing but a file named 1, 2 creates nothing but a file named 2, and this is just a clean command which you can define as cleanx. Okay, cleanx, cleanto, whatever, and you have to use it, make cleanx, right? So it will run the command. So naming is up to you, but yeah. So here what it will print, I don't know, right? Let's run. Now it's up to you, it's your homework to interpret what it has been printed, right? So basically so it depends on 1, it depends on 2. So first it will go to 1, it will create touch 1, right? So it will create touch 1. Now that touch 1 is also printed, right? So this command is also being printed. So if you attach this, then these will not get printed, right? Make hey is up to date. Okay, okay, now echo hey, now touch 1 and 2 is not getting printed. So at the rate, just keep it so that these commands are not printed as it is. Results you care about, right? So now echo, this one is hey, so hey. So let me add at the rate at every command so that this echo is also not printed. Okay, okay, now this echo at the rate, this will take first target hey. Okay, this echo means print, what is this, all the dependencies 1, 2. What is this, all the dependencies 1, 2? What is this, first dependency 1. Okay, these are the special characters. Okay, now the next thing is implicit rules. Okay, so there is something called let me copy everything. Okay, yeah, so there are some crappy rules. Okay, so there is any file, let's suppose any file which ends with o, object file, and which can be made from n.c file using some crappy rules like this. This is a rule which can be used, right? Similarly with cpp, we'll come on cpp later. In cpp is nothing, just with CFLAGS it will come CXX flags variable, with CC it comes CXX, whatever, just move them. What is it doing? There are some specialized variables like CC, and we in Makefile we access variables like this only, as you have already noticed. CC, CPP flags, CFLAGS, right? This. What is it doing? So this crappy rule is if no linking is required, like if there is no external linking that you require from object file, if you all need is just in your current project you want to make a main.c file, you don't have to first make a process.o file, right? You don't have to make first process.o file, then process.o file, then main.c file using this process.o file, because eventually if main.c file is using process.c file, then eventually process.o file will also have to make, right? So if there is no external library, all the internal projects files are there, so it is saying you can use this directly crappy command, this shitty command, right? And if no linking is required, then we can use and no, otherwise these object file are intermediate machine code that requires linking. You can, just forget about this word. This is just saying that if you need linking, use this command. If you don't need linking, use this command. So in case of C, we'll talk about C++ later, but in case of C, this command will translate to your compiler. So cc flag will be your compiler installed on the system. This will remain as it is. CPP flags will be linker flags. So there are some flags like linker flags, right? And this is nothing but your whatever your first target is, right? Then this one, and then your target, your first prerequisite and target. Now this we will use, I'll show you. So this is what it means. In my system, CC flag is GCC, LDF lags is linker flags. So basically if I want to link any external library, right, it automatically will go in Linux, I think your user local libs, something like this, but as of now we don't want to link anything, so it's fine. So libraries to link, okay, ldlibs is nothing but libraries to link, like math library, like we were using math library, right? And if we want to link a object file of math, then we have to use this to link any system library. And if target is whatever you want to define, so target is defined as n, so this is a variable. And how to use variable, $sign, right? Now this prerequisite is defined here as a target, because every prerequisite has to be a target at one point so that your Makefile can run, right? So this target is nothing but it needs this prerequisite, and this prerequisite returns needs this, right? So let me run this. Okay, now I have like pasted for blah file only. Earlier was more generic. Make 8 spaces. Nothing to be done for all. Okay, so here what we are doing is, let me explain you. So here what we are doing here is, so CC is nothing but GCC compiler, right? So we have nothing to do, so no linker flags, and target is n, whatever you want to target. So this is a variable definition, and how to access this variable is like this only. And this variable is also dependent on blah.o, and blah.o is dependent on blah.c. Now though it's your homework to generate blah.c dependency also, but I think you can do like this. blah.c, there is nothing, let's say, to run. So you can put this program in Gemini or ChatGPT and you can check what is wrong here, right? But I think you already understood that this CC flag will be GCC and this is just a C file flag, right? You can even ignore that. So it will just convert to GCC and pick the first dependency, which is blah.c, make the output O, and this is just nothing but target blah.o, right? So this is how it will get interpreted to, right? And this, then after this this target blah.o prerequisite will get completed, and then this file target file will be like a target prerequisite will get created, and now this all file be target will be satisfied, right? So this is how you can use special characters here. Okay, let's move on. So the next thing is how you can use some of the static patterns, right? Okay, got it. So let's go ahead, okay, and let's take an example, bigger example, right? Let's see what it will do. Okay, so now we have one variable objects which is equal to foo.o, bar.o, all.o, right? Now we have one target, so when you will run make, right, by default make will run for all, although it is saying that there is no rule to for this, but yeah. So all has prerequisite foo.o, bar.o, all.o, right? So foo.o prerequisite is fulfilled, but it also need prerequisite full.c. Now let's go to full.c. There is no full.c prerequisite getting completed, right? Now you can see everything is created. Now let's look at this file. So we have target all, right? We have target all, which is dependent on objects file. Objects file is nothing, objects is nothing but a variable, right? Which is nothing but foo.o, bar.o, all.o. So at the end, all is nothing but a target who depends on foo.o, bar.o, all.o, and this is running this command. So cc is nothing but our system GCC, right? This flag is nothing but our system GCC. This is nothing but our free first prerequisite, right? No, this is our all prerequisite, right? So we want to use all these prerequisite, combine them to a single executable. This special character means all prerequisite. Now this is dependent on foo.o, so first foo.o will be run, and this depend on foo.c. Foo.c, nothing, no dependency, just creating foo.c file if doesn't exist. Come back, foo.o will use first dependency, which is foo.c, and operates like make a object file of foo.o. Similar for bar.o, all.o, right? And in all.c, it's not that I am just saying get create whatever is given as the target, like all.c file, empty file. No, I am using some more characters so that you can get used to it. So I am printing echo this code, and this is what a shell command only. This is a shell command. If even I will run here, it will make a all.c file with this code, right? So this is nothing but echo means print something, print this string into this file, okay? And clean command is just that. Now whenever I will make, it will automatically run first target all, right? But if I want to run specific target, I can use foo.c, let's say foo.c target. It will create foo.c file only, which is touch. Here I'll say make clean, it will remove everything, like this command it will run. So this is a special character star, which means everything which ends with C remove. Like star means everything, match everything, right? Okay. Now next comes the part where we can use basically static patterns, right? Let's take an example. So static patterns example is just that you can give multiple targets, right? You can give a target pattern and you can give a prerequisite pattern. So you just have to understand what is a prerequisite pattern. So again, a variable foo.o, bar.o, all.o. This all depends on all the dependencies, this one. And I'm running now. I don't I don't think that I have to explain this command, this one. So it's just cc means a flag which is from gc, right? Let's check. Okay, it's not printing, but yeah. And then what, this is the targets. So this is a single command to generate multiple targets. So it is saying foo.o, bar.o, all.o, take all the targets, and then target pattern, right? So target pattern is this. What it will do, let me explain. It will map one-on-one every single C file with H file. It will map, let's say, test.h with test.c. Also it will expand like this. It will pick first dependency foo.o, right? It will do this. Okay, this is what it will do. So its normal thing is to map every C file with object file, right? Okay, and then these CC flags will nothing but GCC, right? C flag. Then what it will do is pick the first dependency, O, pick the target, which is target here. So similarly it will do for bar.o, all.o. So that's how you can use syntax for static patterns, right? Or pattern generation. Got it? Okay, now there is something called like some other function which is filter, right? So now again, object files I have given, source file I have given, but I want to filter some faltu files, right? Like unnecessary files. Like I want to generate all the object files, except this one, and I want to generate all the source using all the source files except this one. I want to use these only two files. Like these are not files but the variables, but at the end all depends on these object files. Now I want to define a static or pattern matching rule for this, but I want to use filter also. So how you use filter is, syntax is pretty straightforward. Whenever you want to use function, it's like this only. This is the syntax of Makefile. Whenever you want to function, so your function is filter. What you want to filter? You want to filter, so the function first parameter argument goes here, okay, and so argument, this argument on what? This is the function, filter function. So filter pattern list. This is the syntax. Now this syntax is available on the internet, but filter is the function name. What is the pattern? Pattern is this, then comma, then list. List is nothing but this thing. Now it will filter like the target says bar.o, loose.o, right? Then we use pattern generation, which is to, for bar.o, right? It will replace bar.o here. It will bar.c and bar.o, like the last example, exactly same. The only thing is filter. The only extra thing is filter, right? Okay, so that's it for the pattern matching, right? So let's go further, right? Should I talk about, okay, list of commands? There is one thing called list of commands, not frequently used, but yeah. So basically I am defining one variable which is export blah is equals to I was set, right? Then echo blah, right? So something is going on. Then what I'm doing is I'm just printing something, right? Then I'm printing one variable. At the rate ensures that it will not print this line as a output, but the result of this line as output, right? So if I will not take @ it will print this line and then result echo whatsoever and 2, but it will generate. Let's see, this prints I was set. So ये print हुआ सबसे पहले, then I was set 1 is export blah is equal to I was set. So I am just printing this variable when this variable is coming on this terminal. This terminal is making export blah. So export blah is nothing but so this is a export function. So when it's typed on the terminal, so basically when I'm running the Makefile, it's typing something on terminal, right? And that something is actually a command of terminal. So it's exporting a blah environment variable I was set, and it's then running this command. So basically it's nothing but this variable stores a series of command for shell for terminal, and when I am calling that, these commands are being run into terminal, right? But when I am calling 2, now 2 is used using define function. So in define function, now this shell function where I am using make, right? This is a terminal where I use make. When I used make, this will run this variable, and this variable is nothing but a function, shell function, right? So bash function, shell function, terminal function, whatever. It will export blah as an environment variable, but on the next thing, when I will run 2, it is exporting blah as a I was set. It is also exporting, and on the next line it is echoing, but this next time I was set is not being print 2 times. There should be something. Why? Because whenever you define, you use define, there are multiple terminals opened up. So to run this command, one terminal will open, and to next command another terminal will open. So if in first command your terminal is setting up some environment variable, in second command, right, that environment variable will not be present, then you will echo that. So in terminal it's nothing but exporting is to export an environment variable, echo is just to print them, right? So it's simple. Okay, now again, like filter only, you can call condition, like if equals to is a condition, right? If equals to so this condition syntax is if equals to, right? So this is a list, not a list variable. So this is a command in echo, if equals to this, else this, right? Let me run it. Okay, let me run it. Okay, foo feels okay. Now it will run. Nope. Okay, so if else ही है ये. Got it. Now there is another thing called basically variables. You have done the variables. Okay, so there is one big Makefile which is a very great sticky notes right, to prepare for Makefiles anytime, right? This I have myself referred from makefiletutorial.com. but what you have to do, जो भी हमने आज छोटा छोटा पढ़ा, I can teach you a lot about Makefile, I know a lot about Makefile, but I don't want to teach you that because there is only one reason, which is when we'll make our projects in C++ in our next crash course, there will eventually write Makefiles, right? But before that you have LLMs like ChatGPT, Claude, Gemini, and you know the basic prerequisite that I have given you in today's course, and which is more than enough to start anything, right? Use those knowledge to go through this Makefile. Link you will get in the description to the code, to the Makefile, everything, right? Go through it, try to understand what exact each pattern is doing, what everything is doing, then you will know. And also think about it, phony, what is phony, right? It has to do something with files. Basically if your clean file will exist here, something will happen, right? So that is the hint. But yeah, So that is it actually most of the time. But there is one thing which is memory, basically how memory is defined in C or in general, right? That we have to discuss, and then we'll close and wrap up this course. Okay, so your RAM, whenever your C program basically goes through a couple of steps, like your C programs go through basically this is a C program, then it expands, like all the code which you have included will expand, and then you will convert it to assembly, when object code, and then execution, right? Between linker भी आता है जो external libraries को link करता है, external libraries की object files को. But when it runs, when it goes to RAM, your code is divided into multiple things, like how it takes the memory. So first memory is stack. So stack grows downwards. जैसे जैसे stack memory बढ़ती है ये नीचे की ओर जाती है. Heap goes upwards, and there is a buffer, right, where heap can grow, which is called hole also. There is something called segment data. There is something called text. Segment data stores all of the variables which are not initialized, or go to uninitialized data set. Variable which are initialized go to initialized data. Text is just like, let's suppose, your comments, or I would say your normal instruction, whatever you have written in your code. What goes in stack, what goes in heap. Now there is something called, let's suppose you have function 1. Again dependency वाली चीज़ है, function 2. Function 1 is calling function 2, right? Function 2 की body के अंदर function 3, and function 3 let's suppose printing hello world. Now what we will do is कि stack maintain करता है कुछ चीज़ों को. Stack maintains your local variables. Stack maintains your function stack. What will happen is stack is a data structure of last in first out. जो last में अंदर गया था वो पहले बाहर आएगा. The one who entered at last will come at like out first, right? So what will happen is कि first of all the function call here will be recorded. Function 1 will be called, but it will not get terminated because it will wait for function 2 get terminated, because it is calling function 2. Function 2 is calling function 3, right? Now let's suppose function 3 में एक variable है int x is equal to 10 and print x. What it will do? It will store x here in this memory only, stack memory. Now there is nothing after that. It will print, it will remove. So the x was last to enter, first to get out. So it is a leaf for data structure. So this is how stack is used. So x is a local variable, because let's suppose x is defined in this function only. Now function 3 work is done. Function 3 is get evicted. Now after this eviction, this x will be no more in the stack. That's how we flash stack automatically. So scope variables are removed, like the variables which are local to the function or are not global. Then function 2 is also over because function 3 is over. Now function 2 is not waiting for anyone, it's over. Now function 1 was waiting for function 2, but it's now over because function 2 got its work done. Now function 1 is over, right? So it's getting like books are getting piled up, then you are taking book one by one, right? The only thing is ki here, if let's suppose I am like in function 3, I am passing pointer, right? Then this pointer which is stored in the stack will not get like out, right? Though this pointer you have to, this pointer will get out. Now your work is like, if I am passing a pointer to the function 3, what will happen, right? What will happen in that case? That you have to figure it out. In case of pointer, what will happen? But next thing is heap. When the heap will be used. So I've already defined that when you will use malloc, right? Malloc, calloc, realloc, whatever. You are indicating a our C program that you will allocate memory on runtime. When you will be running, then you will allocate the memory. So what will happen is in heap, Heap is nothing but a memory, just a fancy name given. You will take some memory which can reallocate, basically using reallocate call, right? So this memory pointer will be stored in stack, right? So let's suppose this pointer gets out of scope. This was used in function. Now this function got its execution completed. This function pointer got out of scope. The function is completed, so the scope of function is completed. But this memory, who will free this memory? So that's why whatever the function you were using for the pointer, free that pointer in that function only before terminating the function. Otherwise memory leak will happen. Okay, so that's how the heap can grow, because heap can use dynamic memory, and when there is no more hole remaining here, then you will get out of memory error, right? And when there is no memory left for stack, there you will get stack overflow error, right? So that was majorly it in a nutshell, right? So this was a basic to intermediate kind of introduction to C Makefile, and when you will make two projects, major projects, you will get to know a lot more about it. But till then, we'll meet again. Bye bye.